Welcome to our channel, where we unravel the universe's mysteries. Today, we're diving into a jaw-dropping discovery, a giant planet orbiting a tiny star. Meet TOI 6894b, a world that shouldn't exist according to science, yet here it is, defying all odds. Imagine a star just 20% the Sun's mass hosting a planet nearly as big as Saturn. Discovered in June 2025, this cosmic puzzle has scientists stunned. How did it form? What does it mean for our understanding of planets? Stay with us as we explore the story of this impossible planet. TOI 6894b is unlike anything we've seen before. Orbiting a tiny red dwarf star, this giant planet challenges everything we know about planet formation. Red dwarfs are small, cool stars, and their disks of gas and dust are usually too sparse to form gas giants. Yet, here's TOI 6894b, a low-density world that's rewriting the rules. In this video, we'll explore what red dwarfs are, how planets form, and why this discovery is so shocking. Let's start by understanding the star at the heart of this mystery. Did you know red dwarfs are the universe's most common stars? They make up a whopping 75% of all stars in our galaxy. These little guys are much smaller than our sun, weighing in at just 0.08 to 0.6 times its mass. They're cool and dim, burning their fuel so slowly that they can live for trillions of years. That's longer than the universe's current age. Their faint glow makes them tricky to study, but they're crucial for understanding planetary systems. Why? Because they're everywhere. And some, like TOI 6894, even host giant planets. Despite their abundance, red dwarfs are tough to study for exoplanets. Their low luminosity makes them faint, hiding the planets that orbit them. And their small size means any transits create tiny dips in brightness. We used to think they only hosted small, rocky planets due to limited protoplanetary disks. But NASA's TESS mission changed everything, revealing surprises like TOI 6894b. Let's dive into how these disks play a crucial role. Red dwarfs have small protoplanetary disks, clouds of gas and dust, where planets form. These disks are less massive than those around bigger stars, like our Sun, so they lack enough material to form gas giants. Take TOI 6894, for example, only 20% of the Sun's mass, meaning an even tinier disk. You'd think a giant planet like TOI 6894b would be impossible, right? Yet, here it is, orbiting just 0.026 AU from its star. How could such a small star birth such a massive world? To answer that, we need to dive into the mysteries of planet formation. Ever wonder how planets form? The leading theory is core accretion. It all starts with tiny particles in a protoplanetary disk colliding and sticking together to form a solid core. If that core grows to about 10 Earth masses, it can attract gas and become a gas giant like Jupiter. But here's the catch. It needs a lot of material and time, which red dwarfs often lack. That's why gas giants around red dwarfs are rare. Until TOI 6894b surprised us all. Core accretion is tough around red dwarfs. Their disks have less solid material, making it hard to form a large core before they dissipate. With low luminosity, these disks vanish faster, leaving less time for gas accretion. So, forming a gas giant like TOI 6894b seems impossible. It's 86% Jupiter's radius but half Saturn's mass, suggesting a gas-heavy planet. But how did it gather so much gas around a tiny star? There's another theory to consider. Another planet formation theory is disk instability. In this scenario, a massive disk becomes unstable and collapses directly into a gas giant. This process can happen quickly, but it requires a very massive disk, something red dwarfs rarely have. For TOI 6894b to form this way, its star's disk would need to be unusually heavy, defying expectations. Neither core accretion nor disk instability fully explains this planet's existence, making it a cosmic enigma. TOI 6894b is a planet that challenges everything we thought we knew about formation. It orbits a star with just 20% of the Sun's mass, where disks are typically small and short-lived. Yet, here we have a gas giant, hinting at an unusually massive disk or a new formation process. Its close orbit of just 0.026 AU and a 3-day period adds to the mystery. How did it end up so close to its star? Join me as we dive into the fascinating discovery of this enigmatic planet. The discovery of TOI 6894b started with NASA's TESS, launched in 2018. TESS scans nearby stars for exoplanets by watching for transits when a planet crosses in front of its star. In June 2025, TESS detected a signal from TOI 6894, a red dwarf star. The periodic dimming hinted at a planet, but its size shocked astronomers. This wasn't just any planet, it was a giant. TESS's transit data just revealed something mind-blowing about TOI 6894b. The dip in brightness was way larger than we expected. This planet is almost as big as Jupiter, 86% of its radius. But wait, red dwarfs shouldn't host such massive planets. It's puzzling, right? To get to the bottom of this, astronomers need more data from ground-based telescopes. Stay tuned, because this mystery is just getting started. To verify TOI 6894b's existence, astronomers turned to the Very Large Telescope in Chile. They measured the star's radial velocity, the tiny wobble caused by the planet's gravitational pull. This confirmed the planet's mass, about 50% that of Saturn. Imagine a low-density gas giant, larger than Saturn but half its mass. TOI 6894b is like a fluffy, gas-filled world orbiting a tiny star. It's a fascinating discovery that expands our understanding of the universe. TOI 6894b is truly fascinating. It orbits just 0.026 AU from its star, completing a full orbit in just over 3 days. Despite its close proximity, it has a temperature of only 420 Kelvin, 147 degrees Celsius, or 296 degrees. That's surprisingly cool for such a tight orbit. Why is that? Because its red dwarf star is so dim, it emits little heat. This cool temperature hints that TOI 6894b might have an atmosphere rich in methane or ammonia. That's rare for exoplanets so close to their stars. TOI 6894b is a fascinating planet with a cool temperature, making it a prime target for atmospheric studies. Its possible methane or ammonia-rich atmosphere is unusual for a planet so close to its star. These compounds, typically found in colder worlds like Uranus, could reveal clues about its formation. Astronomers are eager to observe it with the James Webb Space Telescope, or JWST. This incredible tool can analyze light passing through its atmosphere during transits. By doing so, we could confirm its composition and shed light on its origins. Why is TOI 6894b so surprising? Its star, TOI 6894, is only 20% the Sun's mass and 60% the size of the next smallest star known to host a gas giant. Such tiny stars shouldn't have enough disk material to form a planet this big. But TOI 6894b's low density and close orbit defy expectations. It's a gas giant where none should be, challenging our theories of planet formation. Let's explore how it might have formed. How did TOI 6894b form? One idea is planetary migration. In this scenario, the planet formed farther out in the disk, where more material was available. Then it moved inward to its current orbit at just 0.006 AU. Migration happens when planets interact gravitationally, shifting orbits. But for a gas giant to migrate so close to a red dwarf without losing its atmosphere is tricky. Could TOI 6894b have survived such a journey? Migration sounds plausible, but it's not simple. TOI 6894b had to form a large core far out, accrete gas, and then migrate inward without disruption. Red dwarfs have strong tidal forces that can strip atmospheres or even swallow planets. For TOI 6894b to end up just 0.026 AU away, it had to navigate these dangers. This makes migration a possible but challenging explanation for its current position. Another hypothesis suggests that TOI 6894's protoplanetary disk was unusually massive. If this disk had more material than typical for a red dwarf, it could have formed a large core quickly. This would allow TOI 6894b to accrete gas before the disk dissipated. Perhaps the disk was rich in heavy elements, speeding up core formation. But such a massive disk around a tiny star like TOI 6894 is rare, making this idea speculative. A third idea is that TOI 6894 was once part of a binary star system. Imagine this. TOI 6894b formed around a more massive companion star with a larger disk. Then it ended up orbiting the red dwarf after the companion disappeared. Maybe it was ejected or merged. This could explain the planet's size, but there's no evidence of a companion star now. So this hypothesis is a long shot, but it shows how creative scientists are getting to explain this planet. Maybe our planet formation models are incomplete. TOI 6894b suggests there could be unknown mechanisms for forming gas giants around low-mass stars. Perhaps red dwarfs have unique disk dynamics we haven't modeled yet. Or maybe new physics is at play here. For now, these are just guesses, but they highlight how discoveries like TOI 6894b push science forward. To test these ideas, we need more data. To unravel the mystery of TOI 6894b, astronomers are turning to the James Webb Space Telescope. JWST will observe the planet during transits, analyzing light filtered through its atmosphere. This could reveal if TOI 6894b is rich in methane or ammonia, offering clues about its formation. Was it born far out and migrated, or did it form in place? JWST's data, expected within the next year, could answer these questions. This could refine our understanding of planet formation theories. TOI 6894b's discovery is a game-changer for our understanding of the universe. If tiny red dwarfs can host gas giants, imagine the possibilities. With red dwarfs making up 75% of all stars, we might be surrounded by more planetary systems than we ever thought. This means a greater diversity of planets, from massive gas giants to potentially habitable worlds. It's time to rewrite our cosmic map and explore the unknown. TOI 6894b is challenging everything we thought we knew about planet formation. Our traditional models, like core accretion and disk instability, just don't cut it for a gas giant around such a small star. By studying TOI 6894b, we can refine these models and enhance our predictions. This could lead us to discover more Earth-like worlds, especially around red dwarfs. These stars are prime targets for finding habitable planets. This discovery highlights why red dwarfs matter. As the most common stars, they're key to understanding the universe's planetary population. If they can host gas giants like TOI 6894b, imagine the possibilities. They might also host diverse systems, including rocky planets in habitable zones. Red dwarfs' long lifespans make them ideal for life to develop. Studying their planets could lead us to alien worlds. TOI 6894 is just the start of this exciting journey. The mystery of TOI 6894b is just the beginning of something big. Missions like Plato, launching in 2026, will search for Earth-like planets around stars. They're focusing on red dwarfs, where many secrets lie. Then there's Ariel, set for 2029, ready to study exoplanet atmospheres. Imagine analyzing planets like TOI 6894b up close. These missions will build on the incredible work of TESS and JWST. Together, they'll unveil the wonders of red dwarf systems and their planets. The future of exoplanet science is looking incredibly bright. JWST's upcoming observations of TOI 6894b are crucial for our understanding of the universe. By studying its atmosphere, we can uncover whether it formed far out or in place. Does its composition match our theories? These insights will not only reveal the secrets of TOI 6894b, but also all planets around red dwarfs. As JWST peers deeper into space, it's likely to uncover more surprises. This is how we push the boundaries of what we believe is possible. TOI 6894b is a cosmic enigma, a giant planet orbiting a tiny red dwarf. It defies everything we thought we knew about planet formation. Discovered in June 2025 by TESS and confirmed by the VLT, this low-density world is a game-changer. It challenges core accretion and disk instability theories. With its cool temperature and possible methane-rich atmosphere, it's a prime target for JWST. Did it migrate, form in a massive disk, or is it revealing new physics? TOI 6894b is rewriting the rules of science as we know it. This discovery shows the universe is full of surprises. TOI 6894b suggests that red dwarfs, the most common stars, could host diverse planetary systems. From gas giants to potentially habitable worlds, the possibilities are endless. It's a reminder that our models are just a starting point. Each new find pushes us closer to understanding the cosmos. As we explore more red dwarf systems, we might uncover clues to life elsewhere. TOI 6894b is just one of many mysteries waiting to be solved. With JWST, Plato, and Ariel on the horizon, we're entering a golden age of exoplanet discovery. Stay tuned for updates on this impossible planet and others like it. If you enjoyed this video, please like, share, and subscribe to join our cosmic journey. Your support helps us bring more space stories to you. Thank you for exploring TOI 6894b with us. This giant planet orbiting a tiny star reminds us how little we know about the universe and how much there is to discover. Keep looking up, stay curious, and join us next time for more cosmic adventures. Until then, keep exploring the stars.